Hello, hello. Is it working? I think it is. Hello, hello, hello. My name is Joanna Nieznanowska. I'm the Vice Dean for the Interfaculty Center for the Education in English Language, and I have the joy and the honor to welcome you on behalf of His Magnificence Rektor and the Dean Wilk and Dean Kwiatkowska and professors of medical faculty to the lecture that is going to be so delicious. As you know, I mean, if you're curious about science and you're scared about regular endoscopy, that might be actually delicious. And as you know, I'm teaching history of medicine, and that's why I am so excited and so joyous right now, because it is such a pleasure to introduce you to someone that actually takes active and substantial part in making history change. But more about that later. Right now, I'd like to welcome the rector himself to the stage to welcome you.
My dear, welcome today. We have the next day with science. Our meetings are very, very fantastic days for our university and our students. Delicious. We see this capsule here today. That is absolutely delicious capsule. I hope so that this this lecture today will be absolutely fantastic with gastroenterology. Professor Koulaouzidis, yes, Koulaouzidis, yeah, Koulaouzidis. This spelling is very interesting because Greek is special language for me, and I hope so that I'm sure that we have the great, fantastic lecture today. It is for us very, very important that we have now today. Gastroenterology is a very important part in the medicine. Professor, we are absolutely happy that you find time to visit our university. And some words about Professor.
Yes, hello. Many of you doesn't know me. My name is Karolina Skonieczna-Żydecka. I'm the Vice Dean for Scientific Affairs, but in Health Sciences, Science Faculty. And it is my privilege today to introduce to you Tassos, in short, who will be talking to you about the delicious topic my colleagues mentioned. We have been collaborated, myself and Professor Wojtek Marlicz with Tassos for a couple of years. As you will see in just a moment, he is the world leader in creating new approaches of capsule endoscopy, and we are involved in microbiome science. So altogether we are having a joint effort to create new solutions for the patients and for the society. So I have a short introduction about what Tassos did, where he graduated from, when, and things like that. So let me read this to you aloud. Professor Tassos is a world-renowned expert in the field of capsule endoscopy and minimally invasive diagnostics of the gastrointestinal tract. He obtained his medical degree in Thessaloniki and then earned 2 doctorates, one in medicine from the University of Edinburgh and the other from the University of Lund. He is currently head of the International Capsule Endoscopy Research Group, leading global research initiatives aimed at further optimizing capsule diagnostics. That's why he is creating the modern gastroenterology, also with collaboration with Pomeranian University. Tassos, and the floor is yours.
Dear Rector, dear Deans, Karolina, Wojciech, who cannot be here today, I feel absolutely honored for all the kind words. I hope I can stay at the level of your presentations. The lecture I'm going to give today is dealing with current status of capsule endoscopy. and future directions that maybe some of us want to take. The next slide will present some of my conflict of interest. I'm going to have to stay a little bit on a couple of them simply because they will be important for the continuity of the talk. I'm currently consultant for one of the manufacturers called Jinsen Science and Technology. It's a Chinese company that produces capsules. And I'm also the president of the iCare group. iCare stands for the International Capsule Endoscopy Research Group. It's a very vibrant and I would say dynamic group of clinicians, scientists, and others who really want to see capsule endoscopy growing. We have currently 160 members, 161 to be exact, and we try to get to the number of 300 by the end of the year. So anyone who has any sort of interest in capsule endoscopy, you are more than welcome to put an application forward and certainly see it favorably. So when we say capsule endoscopy, what exactly we mean? Essentially, for those who have been in the field for a period of time, and I have to say that capsule started about 25 years ago, at the dawn of the century, we all know and we like to present it as a very simplistic device, or at least it has become so. It is nothing more than a vitamin-sized pill that contains a camera, a translucent dome, a camera, some ASIC kind of boards inside, a couple of batteries, most of them apart from one that has 3 batteries, and also an antenna that is useful in order to send the pictures outside of the camera in the little box that it contains, the recording device, as we say. So in many aspects, this is the very typified or stereotype structure of a capsule endoscopy. And I want to remind you guys that I'm really here just standing on shoulders of giants, and that's what happened. The most important people in the development of capsule endoscopy was Professor Paul Swain and Gabby Eden. One was, and you're going to see a couple of pictures of them later on during this lecture. One is a professor, retired now, and the other remains an engineer, electrical engineer, who teamed together in order to produce the first capsule endoscope, as I said, at the start of this century, in 2000. However, and this is a slide taken from Professor Swain's lecture back in Edinburgh when we organized some interest group talks. So that's 2012. You see that he also mentioned that everything is a matter of development that takes time, and you cannot really go in the field just with your own ideas. You have to stand on the work that has been performed before you. It's not only delivering the necessary components, it's various other elements that are not at first sight associated directly with capsule endoscopy. However, you see that they were quite crucial in order to bring the idea as well as the materials together. So the invention of the transistor made it possible for people to think that, oh yes, we can miniaturize things. And after that, Hopkins came in with the flexible fiber optic scopes and ideas. So people said, and Hirschowitz as well, I mean, we're talking about history, let's also point out the right names. And they made it possible to consider that we can view the gastrointestinal tract from the inside. After that, we have the development of what we call the Wolf radio pills that were sensors for temperature and pH, and again, they paved down the path, that they were looking at the path of miniaturized devices for the GI tract. Smith and Boyle developed the CCD, and CMOS came after that made the possibility of capsule endoscopy a viable product. And when we're talking about capsule, of course, you may have in mind the images that exist right now. I'm going to show you, luckily, some images later on, but I want you to know that everything didn't start with a click. Obviously, the images that we're getting initially were not that great. Those are images from the first pill that was swallowed in Herzliya in Israel, and that's the one that Professor Swain swallowed, so that I guess part of Professor Swain's GI tract, and the other is from the one on the very, is it right or left now? That side, it's actually left, so that side is from the first study that it was done, that I think had about 10 or 20 patients in the States, and it was presented in gastroenterology. Of course, the first paper was a single-page paper, which was entitled "The Examination of the Gastrointestinal Tract the pain or the discomfort of the examination of the gastrointestinal tract will be a thing of the past." Well, that's again a little bit was forthcoming. I don't know if we can support this statement now, but this is part of my ongoing discussion. You're going to hear it during this lecture, I hope. That paper apparently was published in Nature in 2000. And those are the images of the current capsule endoscope, or at least the sequence of developments that happen. And as you can see, there's certainly a way better image on the, sadly we lost the video, the playing of the video. But let's try to see it one more time if we can. There you go. So you see that, again, at the very right side, you see the very new development, the PILCAM 3, which is from Medtronic, and the first images of the capsule, the PILCAM 1 or small bowel 1, where you see SB stands for small bowel 1. It's not only Medtronic, of course. There are many manufacturers out there. There are 5 or 6. The purpose of this talk wasn't really to give you all the manufacturers out there, but as I mentioned before, I'm consulting for one of the companies that produces capsules. It's called Jinsan, and this is pretty much the current and the old version of the capsule endoscopes. You very visibly see the difference between the very first version to the updated version of the capsule endoscope they offer. And when we say capsule, is it a capsule for the small bowel only, or we're talking about a capsule for the colon? There was an element of development there, simply because the small bowel is a very tubular structure, where a small capsule that contains a dome in one side is capable of taking images and theoretically not missing major pathology. However, when you go into the colon, where is this kind of more wide tubular structure, and the capsule can tumble with the movement of the colon, people realize from the first studies that one dome is not going to be enough to avoid missing pathology. And for that particular reason, the colon capsule being developed, which, as you can see from the image there, it has 2 domes. So there are 2 cameras, one on each side, that essentially takes images while the capsule moves down the GI tract, and especially down the structure of the colon. Once more, there was also development over there. We see that the first version of the capsule colonoscope, it wasn't as clever as the second version of the capsule colonoscope. There are some elements that had to do with the software, the amount of images it takes. The initial one, the initial version, was taking only 4 frames per second. They realized with this, there is still a pathology, a possibility, despite the presence of the two domes, to miss pathology. And for that particular reason, they ended up delivering the second version, which is the one on your right-hand side, and the one that essentially has 35, or an adjusted frame rate from 4 to 35 frames per second, as well as some advances in the software. But again, there is no, I mean, the point of the lecture is not to give you the nitty-gritty, but an overall idea of where exactly we stand. For this same reason, I'm also presenting the equivalent capsule colonoscope from this other company I mentioned. That's images I should be quite familiar with. This is my colon. Apparently, I took this capsule in order to test the preparation regimen. And apparently, as you can see, you may say, okay, this is not far from the images of a colonoscope, of the regular traditional colonoscope. I have another slide later on that will prove exactly the opposite. We still have a long way to go in terms of capsule image development. And when we're talking about capsule colonoscopes, It's not a monopoly anymore. It used to be, as I said, only one company, the Medtronic, that had, well, it wasn't initially Medtronic, it was given, and after that it was acquired by Covid and essentially acquired by Medtronic. So it's under Medtronic in the armamentarium of Medtronic. But there are other capsules in the market as well. Admittedly, the vast majority of literature and evidence is with the Medtronic capsule colonoscope. What did I say before about the images of the capsule colonoscope? Well, again, as you can see, the difference, one actually at the top, it's a polyp in the right colon. At the bottom, it's a polyp at the sigmoid colon, so it's the right side and the left side of the colon. And of course, the images on the right-hand side of the screen are taken with a traditional colonoscope. But be mindful, this is a traditional colonoscope, two versions before the existing colonoscopes. Still, you can see the difference of the clarity and the quality of the image and also the information that this image carries compared with those of the existing version of the capsule colonoscope. And for those who are difficult to be convinced, well, this is the images of the current version of the traditional colonoscope. Now, don't tell me that you cannot really recognize over here the huge quality difference between what we can deliver with traditional colonoscopy with what we will deliver with the existing capsule colonoscopy. It has to be recognized as a limitation. Nevertheless, all depends. There's always, in life, there's always this story that you can flip a limitation to an advantage, theoretically. And that advantage is that, and what we're looking right now in the clinical field of capsule colonoscopy is to find a way to use the capsule colonoscope as a triage tool. You know that we have this stool screening test, the FIT test, fecal immunochemistry test. Maybe instead of giving the FIT test, we can give a capsule colonoscope to a certain group of patients or individuals who are after some sort of reassurance. Or maybe we can combine the FIT with the capsule colonoscope again in a group of individuals that they have limited chances or low pretest probability of pathology. So that's some ideas that we're working clinically right now, not only in Denmark, but also very active groups in England and Scotland as well, looking at this particular track of research in capsule colonoscopy. I have Sebastian Sostek apparently gave me very kindly this slide, and it's from his lectures in students about the innovation and product development of medical devices, and I really found it as a fantastic and excellent idea. So what he was meant to say is that in order to achieve something, especially in the field of medical devices, you really need to have two expertise groups to meet and also fight together, so to speak. So what I'm trying to say is that essentially it has to do somehow with the amount of information the engineers get from us and the amount of guidance we provide to the engineers as well. So new technology will essentially push through a novel technique. The novel technique or technology will require development, as you can see, of other novel techniques, and technology push through a novel technique again. So it's a kind of wavy field of development. My problem, and the reason I got involved so much with capsule endoscopy, was the fact that I felt that at some point there was a standstill of imaging capsule endoscopes. So I had this obsession, let's say, oh, let's do something more. Is it possible to look around and get some extra sensors into the capsule pill? I now call it a deadly attraction, and I explain later on what I mean by this, simply because sometimes you have to accept the limitation, as I said, use it to your advantage without trying to push over and beyond something that maybe is not bound to develop to something else. But that's also a huge area of discussion, maybe also philosophical to an extent. So I keep talking for the last 10 minutes about this line of production of or new developments in capsule endoscopy. So a very good friend, a mentor, Professor Toth, gave me this slide, and I think he used it quite often. And with his allowance, I can present it to you as well. So that essentially shows pretty much the same story of development that started way before 1998 and continues probably 7 more years from 2018 now, but it gives you an idea where we all stand. I would like to point to you the story of this smart pill, the one in red that says FDA approved. That used to be a really clever way of measuring temperature in the GI tract, contractility, and also pH in the GI tract. Somehow it has been stopped, so that they don't sell it anymore. It was in the armamentarium of Medtronic. And I would also like to point out this big device that shows looks like a globe above a table. This is the magnetic capsule used for the gastroscopy or the wireless gastroscopy tests. And the Atmo capsule that is still under development and going through, development and clinical trials, so it's kind of post-marketing development, that detects gases in the gut. Going back to the GeneSand platforms, once again, there is, as you can see, various products, including the gastric or the capsule gastroscopy. That's probably a better way of saying it. The high definition small bowel capsule and the colon capsule. But everything seems to be improving. Once again, some images from that particular type of scope. But look at this device. And sometimes you need to take a step back and think why people are still questioning the lack of acceptance or adoption of this device for gastroscopy in the western side of the world. And the reason is you need to dedicate a full room of your endoscopy suites to house this stuff that cannot be used for anything else. And that in many aspects is the main reason why Western gastroenterologists or Western educated gastroenterologists are very reluctant in adopting this technology. There is still a lot of push, maybe from manufacturers, because this is not the only. As you can see, the next one. Well, I promise you an image of Paul Swain. So that's Paul Swain swallowing a gastric capsule, a magnetic capsule, as we say, in the very early development stages. So that shows the dedication, of course, of the man. And I'm pleased to be able in my lifetime to listen to Paul. He regularly visits us in Denmark every September for this meeting that we hold in Denmark called Reflect. Apparently the reason that we named it like that is, it was a clever name actually, but it's an abbreviation that comes from the future of non-invasive GI technologies and platforms, but somehow through some acronymify ways we managed to call it Reflect. But as I said, Paul is a true polymath. He can put his head down when he delivers a lecture and just tell you almost everything about the subject if you ask him to. And we kind of, to an extent, last time we gave him a subject that was completely different to his inaugural lecture in Edinburgh then, and he managed to nail it in a way that it's completely mesmerizing. In any case, I'm not going to say anything more the achievements of the man speak for himself, in fact. But wanted mostly to point out that the area of development of the gastric capsule has also taken a big kind of circular path, starting from the very left side of the screen, going around pretty much like a clock. And we have these devices, third generation devices, or second generation devices as we call them up there, and third generation devices. But yet again, as I said, it is a different, it's a different beast. I mean, you cannot really put this stuff in your endoscopy suite unless you have a lot of space. Once again, Sebastian was very kind to give me this slide just to show the developmental stages of a product, which starts from the idea to maybe engineering development, and after that the clinical studies, the regulatory path, and the post-marketing checks, and all that comes with the pain of investment. So you invest quite a lot in the initial stages, and after that, and after that, actually, the lot is becoming even more. In order to have some mild revenue, that's why quite a few of these ideas and what I call deadly attractions before are not getting into the market. Engineers have their own kind of paths and sometimes their own agendas. They tend to listen to us, but not too much. And that's why they come up with some devices that are not particularly applicable in clinical practice. So essentially what you want to do in order to get a step forward is to try to provide a solution for a problem and not problematize a solution. And that was my kind of yearning in the world of development of capsule. I don't think I managed to offer that much, so thank you for the kind words, but it's just another issue. You hear, of course, AI. AI is all around us, and you see in this one that if there was any major development in capsule endoscopy, the last 5 years was based on the AI solutions. And we have not only manufacturer-based solutions or proprietary solutions, but also generic solutions, pretty much like the three squares at the bottom. Very selected. I'm pretty sure that the companies that offer AI solutions are way more, but that was an attempt to do a landscaping of the story. And as I said before, this is pretty much the major development that happened in capsule endoscopy the last 5 years. Cloud-based solutions as well, they seem to be a very good alternative. From the Jinsan company, again, we have this study that was published in JAMA a few years ago, and I think it was 2022, and it showed that their proprietary system called SmartScan was capable of detecting 10% more findings than the regular gastroenterologist. And the more crucial thing is that it reduced the time of reading, which I forgot to mention, that reading the capsule is also as time-consuming as getting a capsule in. Extremely delicious product, but at the same time it just requires a lot of, let's say, post-ingestion care. And that can be monitoring your patient, also part of delivering the report, because it has to come through a human being, the report, up till now. So we're trying to change that with the advent of AI. And in a recent meta-analysis, we managed to show that from the proprietary available solutions, all of them are capable of reducing the amount of time that is required for reading. Another attempt takes place in Britain. As you can see, it is called C-scale study. It's coming to conclusion, and I think there are going to be a few manuscripts out the next few months about this. But once again, I would like to point out that the main aim of this is not only to increase the detection rate in capsule colonoscopy, but also to reduce the time that the report is available, will be available. Similar research happens with the other capsule, the Jinsan capsule as well. Poland is part of a 4-nation study in this aspect. There are 3 more centers in Portugal, Sweden, and Denmark, of course. And we were trying to see whether swallowing the capsule at home with the use of these boxes and some clever AI solutions is going to be capable of providing us the same results in terms of safety and, of course, in terms of reporting. That's very deep, and I'm not going to go into any detail. It was an attempt from a very close collaborator on the field of AI to highlight the various programs that have been awarded through the Horizon, the research, the European research field. And over here, the reason I have placed it in this lecture is just to show that out of this, the majority of the outcomes didn't lead to any tangible product. They developed modular improvements in various elements of capsule endoscopes, but there wasn't any product that came out that is called Troy, Aris, or Nemo. Very clever name, by the way. Smart pill, the one that you see, smart pill, is not the same as the smart pill, if you remember the previous slide with the red tag mentioned before. It's something completely different. And when you say soup cam, it comes from the submarine or suppository type of cam. It's a global, used to be, it's not a product. In fact, used to be a global, not global, a spherical device that you insert from the bottom and somehow magnetically you control through your colon. So I think you realize that maybe the main reason of giving you this slide is to, again, make you realize the difference between the engineering path and the clinical need. And also this, if you remember this wavy line, that's extremely important to have in mind that, you know, the pushes that happen through the engineering doesn't necessarily reflect the, let's say, the indentations we expect to happen in clinical care from our side. So, and just to make it a little bit more fun, this is the type of devices that have been produced with some of these projects that I mentioned before. The little funny thing, the one that you see with the rotor or the little wheels that somebody is pulling it through, it was an attempt from our lab to do some auto capsule, as we used to call it. Of course, it didn't go any further. So the beauty in research, I think, it comes into the failures of research and not, I mean, yes, of course, there is success is necessary, but also the failure in this area is extremely important because it makes you understand that was daft. Perhaps I shouldn't have done it. And that's the one that you see with the animation, the little kind of man that holds a device, and now it's a sphere, a magnetic sphere. It's from the ENDO project, which was part of the Horizon that we've been partners in. Now we have the clinical agenda that, I mean, as I said, it's another thing, the engineering agenda, and I think the clinical agenda. Also, I forgot to mention in this previous slide that at some point when I was asked to do a keynote lecture about capsule endoscopy in Portugal about 7 years ago, maybe a little bit longer, I used this abbreviation again of the tidal wave. So in order to make a huge difference in the area of capsule endoscopy, I felt that you really need to do this, taking the abbreviation, deliver therapy through capsule. Okay, where we stand on this? There is one slide later on that explains integration. Incorporation is probably integration of smaller devices and incorporation of more technologies. Again, I'm not sure that we are in the process of having tangible products within the next 3 or 4 years. What happens after that is a matter of discussion. Data collection is probably the only area where the artificial intelligence has made a huge indent or impact. Actuation of the capsule, we haven't still seen any caterpillar capsules or odometer capsule, as I explained, and localization of pathology in the GI tract. Keeping that in mind, with this abbreviation of tidal, a friend and my PhD student, kindly, Pablo, has attempted to do this presentation of what is the clinical agenda, out of which, through these various words, I'm going to eliminate few, and I keep only this alternative imaging and sensing. And by alternative imaging, I mean anything but white light imaging. Whether this is going to come in the form of capsule endoscopy within the next few years, it's again a matter of open discussion. Sensing, I have a couple of possible solutions. The C-scan was a CT scan capsule. This is an OCT in the middle of it, and I can't remember what is the one on the very far side. And the sensing capsule, it was it was the ultrasound capsule through Sonopil. But fair enough, the sensing is actually sensing of parameters. As I mentioned before, there was one capsule that looked at temperature and pressure, the smart pill, but that has been taken off the market, and biochemical parameters like gases and soluble biomarkers, out of which the very last one is the one that I would probably put all my money in for the next 5 years, meaning soluble biomarkers. The problem is to find the biomarkers first before you go into sensing them. What did we say about failures? The life of a clinician and also a researcher is full of failures. That was one of the most painful ones. That was a project that we submitted in the European Union about 11 years ago, first time in 2013. After unsuccessful resubmissions, we never managed to get any money, but the dream was there. In fact, the idea was actually there from the first moment. So the whole idea is to give a pill at home. The pill detects automatically inside the pill whether there are polyps or not, and you can call the patient for either an examination or back again in a couple of years to re-examine. So this story started as a consortium that was since dissolved. Nautilis, by the way, stands for, if I remember, let me see if I remember it well now, Novel Autonomous Intelligent Endoscopic System. Well, where people fail asking for money, some others, without money, produce that system. So this is a prototype from Denmark, from the team of Ismail Nadimi, who has really kindly gave me the slide as well. It's a big pill, so they're essentially hoping to miniaturize it, and I hope they succeed as well. Ismail is a good collaborator, and hopefully we'll be able somehow in the future to look back into this again. And where we also fail, we don't stay, we move on, and we manage to move on through the ICE. ICE stands for Artificial Intelligence Capsule Endoscopy, a successful Horizon grant that has been awarded in Denmark, and other partners, of course, that participate in this consortium. I wasn't there when I moved to Denmark about 3 years ago. It was Gunnar's main kind of proud work and the brain kid of Gunnar Bartrup's research. So that's, as I said, colon capsule endoscopy and artificial intelligence. As you can see, these algorithms that are still in the process of delivering them. Hopefully it will finish in the next, let me see, August 26. So it's not far from the finish line. So we're wrapping things up, and hopefully we will be able to deliver something that have some clinical application as well by the end of it. So taking a step back, up till now we kind of discussed about imaging capsules and all the possibilities, so to speak, to have some extra components in. And I think to an extent everything comes from the idea of having this clever device like the smartphone and stick everything into the capsule. Nevertheless, the smartphones, I think instead of getting smaller, they're getting bigger and bigger because you want to put more functionalities in. With the capsule, it's impossible to stick everything you like, including biosensors and whatever else in the capsule. And that's why I call it a deadly attraction, simply because it comes to the point that you have to accept that you reach the maximum within the size, unless if somehow there is also development, pretty much like the first slide, of extra breakthroughs, smaller batteries that are biocompatible as well. It's impossible to fit everything in the size. It's a very certain size. You cannot go beyond that in the shell of the capsule. Another kind of deadly attraction was this story of having 3D representation or 3D reconstruction of the structures that you see in the GI tract. This capsule has been was marketed, and I think I haven't seen any major development, so I don't think it has been, let's say, adopted by the clinicians. And in all honesty, when I see that, I don't recognize a huge difference. So MC4000 is really the 3D capsule. I don't recognize any huge difference between the 2D images that you see on the left-hand side to the ones that you see on the right-hand side. Theoretically, the 3D reconstruction images. Now, the reason I put this one, I'm getting now close to the end of the lecture, is just to point out that apart from the imaging, the white light imaging, there are many other possibilities based on the modality that you use. And in fact, I show you one confocal, I think, capsule in a previous slide, but I will stand on the autofluorescence imaging or fluorescence imaging, simply because it can penetrate deeper into the human tissue, into the structure. And there are also some attempts to do something like that, out of which this is the first attempt, 2000. Again, it didn't run. It didn't actually get through. It didn't take off, let's say. Nevertheless, I was really pleased to see last year, or the year before, I think it was 2023 or 2024, that the Chinese group has managed to do a capsule that looks very promising, and I hope they get beyond the stage of the lab. So this is still a prototype, but it combines three major elements: the near-infrared fluorescence, an AI, and also magnetic. I don't know if that's the benefit of it, but it's a magnetic kind of manipulation of the capsule as well. So, going back again to Paul Swain, so what did Paul Swain think about the development and the future of the capsule endoscopy back in 2012? He thought that from the specific organ-specific capsules, we'll eventually move to something that looks like that. And as you probably know, we haven't reached that point yet. And we're talking about 13 years down the line. I have to say that when he said that slide, he also had a supportive slide saying that don't listen to me, because people who discover stuff like Einstein, Bill Gates, or there was, I think, Thomas Edison, had some quotes from what they were saying in a completely kind of different direction to the way the technology has been. And we attempted at some point to let's say, put the landscape out there, what kind of developments and devices have been. And we're not the only ones. There are many groups that attempted to do the same. And as you can see, there is a lot of work. I use in video, I think, or something similar to, and I don't know if you can play that, but I'll try. Just as a fun last, or I think it's one before last, the penultimate kind of slide. So. Yeah, okay, that's pretty cool, right? But I mean, this is amazing still what AI can do. So maybe essentially the only major development in capsule is and will remain AI. I really don't know. As I said, this is the closing one. So future directions in capsule endoscopy. AI-powered image analysis, I think I've already said that too many times, nothing to add. High-resolution 3D imaging, fluorescence, and wide angles of lenses, potential also area of development, bidirectional communication, real-life control, feedback from physicians, active locomotion, magnetic propulsion, robotic legs, and soft actuators, I'm not sure. I mean, about the last one, probably there is an element of truth in some area for further research, but I still struggle to think of a successful soft actuator. Therapeutic capabilities like drug delivery, hemostasis, biopsy, and lesion ablation, I wish we can at some point see a capsule that provides this sort of therapy. And I would love to have this as my major kind of title of this presentation, saying that therapeutic capabilities is the future of capsule endoscopy or capsule research. Longer battery life, not part of the area I'm touching, but certainly if somebody comes up with a clever kind of battery that's compatible as well, that will change everything as long as it's a smaller size battery. Smart capsule networks, I think I'm not going to stay too much on this, and multimodal diagnosis, the deadly attractions again, hybrid systems with everything under the sun, including microbiome, and I think Carolina will really like this. I'm not sure about that, Carolina, but that's obviously an area of research about the connection with the capsule, I mean. And with this slide, I'm going to close the lecture. And thank you for your attention. I hope you enjoy part of the talk. And at least if you find it useful, that will be great as well.
Sir?
Thank you very much for this excellent lecture about the future and for all this way between the old capsule, the new capsule, the small robots, or what else. But my question is, what is your opinion or your imagination about what's happened 10, 20 years? It is the traditional colonoscopy just on the history of medicine. And what's about the indication and contraindication? Because the simple diagnostic of tumors, maybe this method is absolutely better. But what's about the inflammation disease and acute states of this bowel disease? What's his opinion?
Thank you. I try to... But yet again, I only had a vision for the next 5 years, and it doesn't seem to be possible to change that much in the next 5 years. However, in 20 years' time, I totally agree. With everything converging to something that is maybe completely different in terms of delivering the care from diagnosis to therapy, it's not impossible to consider that there will be a wireless device. I don't know if it's going to have the form of capsule, but certainly a small wireless device that can deliver diagnosis on board and also delivery of or release of medications in areas of that will obviously be the dream of every gastroenterologist and really fantastic person. It's something that you hear a lot in the area of the capsule. Contraindication, I mean, as an obstruction that blocks the further passage of this device. Nevertheless, if we're talking about smaller and smaller and smaller, even the Crohn type of strictures or any other strictures can be bypassed. Not to say that essentially there is this capsule called patency capsule, so it's a dummy pill, it's a sugar pill that essentially if people swallow, people with high risk or high pretest probability of a lesion, of a stricture, they swallow that to confirm that, okay, it's safe after that to give the existing size capsules. But, I mean, the future theoretically should offer smaller devices with more capabilities. Not too small, though, of course, yeah, absolutely. But in 20 years, yeah, I'm pretty hopeful that there will be a completely different world around us. There is actually, yesterday I was browsing YouTube, there is a very interesting guy who has a Greek ancestry called Peter Diamandis, who speaks all the time about the singularity moment, that essentially there will be something completely different in a very defined time in the future. I think it was initially placed in 2047, and after the more we progress, it comes down, and I think it's now, I said it's 2031, somehow everything will change then. I don't know what exactly will happen in 2031, but certainly very frightening and exciting at the same time.
Dear audience, any more questions?
We collaborate with Tassos. However, do you have, if there are any attempts, except for our needs, to create a capsule that will have a container inside, to open inside the small bowel to give us the sample of the juice that we want to evaluate? Because as far as you know, maybe you don't know, but we are both working on the topic of gut microbiota, and we evaluate only stool, and what's the most important is located in the small bowel. But our possibilities to obtain the juice from the small bowel is limited, so maybe that's where the capsule goes into the action.
So, currently, really pleased to know that this is the most hot topic in the current research field. So the majority of people from the groups I know switched on from, okay, we'll try to give a better resolution or whatever else, getting other capabilities, including that as number one, sampling. I see some problems there, but yet again, as I said, problems and failures are probably the best kind of partners in this path. As a closing statement is that I see it as number one hot topic at this point. Whether we're going to deliver capsules like that, I guess there are already some of them. If I remember well, there's a capsule called Simba capsule from Nimble Technology or whatever in the States, and there are two more that are in pre-marketing stage, I think. Plus, I have two groups that I know that they're working actively in this area. I can get you in touch if you want with the...
Thank you for a very excellent lecture. Till today, I thought about this capsule only when I think about the diagnosis of the small bowel. That's why I'm impressed that we can diagnose upper part and lower part of our gastric digestive tract. And I think that it can be very good solution for screening, maybe not for diagnosis for ill person with symptom, but for screening, because people after 50 should have some endoscopy. And many of us, because I'm after 50, doesn't make this diagnosis because it's not nice. That's why I think it's some kind of direction. Next direction, I think it's treatment. Like you say, this capsule can deliver some drug, and very interesting is that can be a sensor of some biomarker, some gas. I think other kind of endoscopy, it's impossible to make things like this. That's why, in my opinion, this is a new direction. And I think the best solution will be diagnosis of all digestive tract with application on the phone, of the mobile, at home. Yes, I think this will be good direction, because we have now more and more cancer. Our diet is not good, our lifestyle is not good. That's why we should make more and more screening, but we don't make. Yes, I think it's my impression after your lecture. Thank you.
Well, thank you as well, because you almost summarized the exact pain points that we're working currently. To be a little bit more specific, we have 2 minutes. Screening. Why capsule, colon capsule, any sort of capsule has somehow failed into screening right now? Because of the high probability
of pathology. So the moment you have feed positive at a certain level, you're going to have some sort of pathology. So you will have to treat that pathology. So why to give a capsule? That's why in fact, there is a gut paper coming out, hopefully the next couple of months about this, the biggest study from Denmark in this area. The other one is really, as you said, biomarkers, and that's absolute my number one priority, let's say, or the holy grail. Biomarkers in the entire gut pre-disease, before the disease is kind of developed to the point that you need major therapeutic interventions. I think the moment, in my lifetime, if I see that, I think I would use, thought that the capsule has really delivered this beyond you remember that slide with Paul Swain's kind of submarine capsule? That's pretty much the equivalent. Okay. Now, a very critical, a very nice question, in fact. So, not only this, in the old days, people used to have more aggressive preparation. That's what kept colon capsule to an extent in one side. Because everybody said, oh God, and if I had pathology, so we're going back to the story of the pre-test probability, it's going to be a disaster because I will have to go to a colonoscopy. So instead of having one procedure, you're going to have two procedures. However, there is a recent development about 5 years ago, 4 or 5 years ago, of a major, let's say, the magic bullet in the area is a tablet called prucalopride. So the moment you take your capsule, colon capsule, you take your prucalopride as well, and the majority of the test, the capsule really shoots out pretty quickly. So we're talking about transit time, total transit time, between 2 and 5 hours, which is fantastic in many aspects. The problem still that remains is that if you have pathology, then you have, and that's where the money is at this particular point in the clinical research area. Identify the group of those who want reassurance, but they have high pretest probability of no pathology in the colon.
Thank you, Professor, for your great lecture. I must tell you that during the listening to your lecture, I was thinking about development of the AI, of the artificial intelligence. So basically, I think that in this audience today, they are people who are really into AI and against, but we must admit that without AI, we wouldn't have this progresses, including the science. So we cannot stop it, definitely. We cannot stop AI development, but we need to use our head all the time not to stop thinking, but we need use and we need to take it from the best side and take the best from it. So thank you very much, because you show that AI is really needed in a good way, of course. Thank you.
Thank you. And just to add, because again, I was very against AI at some point in life. I thought it was way more gratifying for me as a researcher to provide a new capsule, hardware capsule that will do magic stuff. However, I can say if anything has made a major difference in capsule right now, it's AI. So that's the one that had allowed us to make one step forward. It seems to be an easier, I don't know, regulatory obstacles are there for everything, but it seems to be something way easier to deliver than the hardware. I think we're lacking the background science that allows us to get a better hardware-based capsule.
I also have a question. Very sci-fi stuff. First, bummer. I'm too old to wait technology to avoid colonoscopy, so yeah.
Colonoscopy apparently is I mean, we shouldn't be, one thing we don't want to victimize colonoscopy.
No, it's a fantastic procedure.
Correct.
Provided that it's done by the right people.
Correct.
I'm just scared of things being stuck my bum.
Yes, true. I mean, it's
that's
always
just me, or maybe not just me. But my question is, we are talking about screening, we are talking about the use of CE as diagnostic modality, but also in perspective therapeutic modality, maybe. I imagine it's horrendously expensive. For something to become a screening, we need to have a good balance between the cost and effect. And also for something to become a diagnostic modality, we need the same. We need, a lot of oomph for the money. Outside of small bowel, how do you think, where are the regions where we could obtain this, attractive balance between cost and effect?
I have a big grin now in my face simply because the study we're doing right now in Denmark is called DANCAP, and it's something that has been, let's say, imposed by the region, saying that if you want us to adopt anything, you have to prove to us that there is some cost efficiency on what you're doing with colon capsule endoscopy. I don't know if we will achieve, because as I said, all depends on the test population you choose, but absolutely spot on when you say it has to provide that extra oomph for the kind of organized healthcare systems of the West. For the future, what area will provide that? I think again, I'm going to have to think of therapy, localized therapy, because if you treat the earlier you treat, the earlier you diagnose and treat, theoretically you avoid, for instance, Crohn's disease. I mean, what if there will be a capsule in the future that can realize, okay, you have a high probability of developing little small after lesions are treated with a local spray of some substance. Many elements are missing, many blocks are missing for that, I guess, right now. But it could be something very tangible in the future, I guess, and this 20 or less, hopefully, years vision that we.
Any more questions? Is that a hand raising? No, nothing. I understand that the student part of the audience are just crossing their fingers or toes that the technology will develop fast enough for you not to have the dilemma that I am now going through. To go or not to go, and where to go, and when to go.
But also I hope we excited some of them to be part of the genesis of the new kind of
For this lecture, it was important. Using technology, AI, it is absolutely for us important. And this, it is small for you. Thank you very much. We are honored. Thanks a lot. Absolutely.